A snail crawls 1.3 centimeter per second. Express that speed in marathons per fortnight. Well, that's a bit hard, isn't it? That's a bit out of the pocket, a bit random. To do that, you're going to need to know basic conversion first. Then you can focus on conversion gone wild. So, first, let's go over unit conversions, okay? There's something fundamental that you need to know. You need to know the metric ladder from top to bottom. Now, what is the metric ladder? It gives you a base unit like a meter, a kg, or a second, one of the SI units we used beforehand, right? And then from that unit, you have other units to represent it, other prefixes to represent this unit. Now, what do I mean by a prefix? For example, if I had meter, right? Kilometer would be km. So k is before m, and it makes it a prefix. And the prefix k represents 10 to the third, which is 1,000. Okay? This means it's 1,000 meters. Now, there's a way to memorize these prefixes, which is King Henry died by drinking chocolate milk. That's not actually true, but this is a nice mnemonic to memorize it, okay? King would be K for kilometer or kgs, which is 10 to the third. Henry is hecto, 10 squared, which is 100. Died is deca, which is dA. Base is none, so its base is by. Drinking is deci. Chocolate is centi, and milk is milli. So it starts at 10 to the 0, which is just 1, and it either multiplies by 10 or it divides by 10. That's how unit conversions work. Now, why would we use unit conversions? Well, if you're looking at things like the breadth of a hair or the length of a wave, then you're going to need really small units. And you're not going to always say 0.0000005, right? Sometimes you might just want to use units to represent it easier. So instead of saying 0.00006 meters, you could just say 6 micrometers. Isn't that more concise? And then, yeah, so these are other units that are used frequently, but are not on this like King Henry mnemonic. This is micro, which stands for 10 to the negative 6, and this is nano, which stands for 10 to the negative 9. So these are smaller units, okay? Now let's go over how to convert between units. You have to slide the decimal step by step. Now, you start at the base, okay? And then if you go backward, you slide the decimal to the right. What do I mean by that? So if you had 200 meters and you wanted to convert it to centimeters, it's 200.0, right? If I slide backward 1 to deci, then I would change it to become 2000.0 decimeters. But I want centimeters, right? So I'll slide this 0 one more time to make it 20,000 centimeters. Because I have to count how many orders of magnitude or how many tens are they apart from each other. Okay? So, since there are 2 tens apart from each other, or 2 orders of magnitude apart from each other, I would multiply it by 100, because it's times 10 times 10. If I want to convert this to this. Now, suppose I got something that said you have 5 kilometers, converted to millimeters. How would I do that? I would say 5 over here. I would count how many tens goes to milli. 1, 2, 3, 4, 5, 6. So I would multiply it by 10 to the 6, and I would get my answer for millimeters. Now, if you wanted to convert it the other way, which is from small units to large ones, if you want to convert from millimeters to meters, suppose you have 2,300 millimeters. You'd still count how many tens it goes. So 1, 2, 3. But instead of multiplying, you'd move the decimal to the left, which is dividing by 10. So you'll divide by 10 to the third, or 1,000. So then what does this become? It becomes 2.3 meters. All right? So good so far. And regarding micro or nano, this skips a bunch of steps. So it's a bit harder to keep track of these, right? Because you can't just go counting like this. So you'll have to use these, -9 and -6, these exponent, to figure out how many units away is it from the base. So then you could know that if something is 20 micrometers, it's 6 units away from the base because it's 10 to the -6, right? Micro. So you can divide it by 10 to the 6 to get, 2 times 10 to the -5 meters. Or you could just substitute in 10 to the -6 for micro, right? Instead of the prefix micro, you can just substitute 10 to the -6. Becomes 20 times 10 to the -6. And then meters. So far, so good. There's weird conversions, though. You can say 1 meter is equal to 100 centimeters because, meter, decimeter, centimeter, right? How many tens between them? 10, 10. So 1 meter is 100 centimeters. But what about 1 meter squared? Well, I just have to do a bunch of algebra for that. I would square both sides, right? So 1 squared is 1, and meter squared is just meter squared, 1m squared. But then what is 100 centimeters squared? Well, first that would be 100 squared times centimeters squared, right? That would become 10,000 centimeters squared is equal to 1 meter squared. Now to get a bunch of intuition on why that is, right? If you look at this, meter squared is a representing area. So it's a larger unit than a meter. That's why centimeter squareds have to be larger as well to compensate with the two-dimensional grid here. Otherwise, centimeters, you can't compare centimeters to meters squared, right? Because these are different dimensions. This one is regular 1D objects, and this one is 2D. So that's why you need to use these conversion factors. If they ever give you 1 meter squared or kilometer squared, just set it up into an equation like this. 1 kilometer is equal to 1,000 meter, and then you can square both sides to find out the rest. That's how you get squared conversion factors. All right? Cubes are very similar. Now you're not looking at area, you're looking at volume, okay? So 1 meter is equal to 100 centimeters. But when you cube this becomes 1 cubed times meter cubed is equal to 100 cubed, which becomes 0, 0, 0, 0, 0. Because 100 cubed, since there's 2 zeros, there's going to be 6 zeros, right? Now, that's going to become centimeters cubed. So this one is obviously larger, right? This ratio is larger than the centimeter squared was, or the regular centimeters was. So it's the same process as squared, but it's just one more exponent. So keep that in mind. Or you can memorize this, right? Area is 10 to the 4th when you change between dimensions, and volume is times 10 to the 6th when you change between dimensions. You could use those, but I find this more intuitive. Now, if you're ever going to convert regular units, right? Not too complicated. So let's try this. First, I'll pause and I'll let you guys take a go. And then let's go over the units together. So first, how would I do this? I would write down that 2.5 kilometers, right? And then what do I want to convert it to? I want to convert it to meter. So I'm going to define a relationship between kilometers and meters. Meters are here, decameters, so DAM, and then becomes hectometers, and then kilometers, right? So 10, 10, 10. 1 kilometer is equal to 10 to the third meters, or 1,000 meters. So 2.5 kilometers times 1,000 meters over 1 kilometer will give me my answer. Because this is a true ratio, right? You can think of this as the same thing as 1 over 1. Because 1,000 meters is just the same as 1 kilometer. And like this, you're allowed to cancel out the units. Kilometers cancels out. 2.5 times 1,000 becomes 2,500 meters. You always multiply by this conversion unit. So let me look at another example, right? 500 grams to kilograms. I'll define the same relationship. 1 kilogram is equal to 1,000 gram. And then I'll look at 500 gram. What do I want to cancel out? I want to cancel out the G and make it a kg, right? So whatever I want to cancel out goes in the denominator. So 1,000 grams goes in the denominator, and 1 kg goes in the numerator. G's cancel out, 500 divided by 1,000, which gives me 0.5 kgs. Not too bad. Now here we have meters squared, right? Which would just be 1 meter is equal to 100 centimeter. I squared this. 1 meter squared is equal to 10,000 centimeters squared. So then 3 meters squared would just be 3 times this, because you multiply both sides by 3. It becomes 30,000 centimeters squared. Or you could use the fraction ratio like I did. Either way does work. And then this one we already went over, so I'm not going to go over again. What number do you really multiply by? You see all these fractions I'm using here? Like I said, right, 1,000 meter over 1 kilometer, that doesn't change anything because that's basically 1 over 1, which is just 1. Because both of these units are equal. It's just different ways of representing them. Okay. Now for what you've all been waiting for. Let's go over the more crazy ones. All right. So 1 Shrek is equal to 93 minutes, which is almost a whole movie. How long is a 24-hour day in Shreks? Not in hours, but in Shreks. Well, first I define my relationship. 1 Shrek, which I'll represent as SH, over 93 minutes. But now what I'm going to do is think about what you want. You want Shreks per day, right? What's going to be in the denominator then? It's going to be day. So I have to find a way to cancel out units such that denominator is day. So first I have to get rid of this minutes. How would I do that? Well, I could define a relationship 60 minutes over 1 hour. Okay? Now, why did I do hour? Why didn't I do something else, right? Like seconds. Because I want to cancel out days with hours. So then I can do 24 hours per day, right? But which one is it going to be? Day per 24 hours or 24 hours per day? Well, if I do 24 hours per day, then I can cancel out the hour and hour. And I can get D on the denominator, which is what I want. But if D was in the numerator, it would be harder to get it on the denominator. That's why I'm going to keep D in the denominator for now. Okay? So then I have my expression, right? If I just multiply minutes and minutes, these cancel out. Hours and hours, these cancel out. Shrek is on the numerator and D is on the denominator. So I just multiply my numerators together, which is 60 times 24. Okay? And then I divide that by 93 times 1 times, this should be 1 day, times 1, which is just 93. Now, if I was to use my calculator, this gives me 15.48 Shreks. So yeah, I always round to 2 decimal points, which I find more useful. Okay. Now, we're going to go over the more daunting problem. This one is a tad bit more difficult than the first one. Same steps. You want to see what you want in the numerator and denominator, but this one requires more conversions. Why is that? Well, this one, we had Shreks in the numerators already. But for this one, we have centimeters. And what do we need it to be? Marathons. So I'll show you how to do this, and it's going to be a tad bit different from this one. Okay. First, I write down my relationship. Always the same step. 1.3 centimeters per second. Now, think of what you want it to be. Marathons per fortnight. I'm going to define a marathon as a MA and a fortnight as a FN. Okay? Now, I'm going to do 1.3 centimeter over a second, and I'm going to look at what I need to do to change the centimeter to make it marathon in the numerator. Okay? And I want to change the second to make it fortnight in the denominator. First, I'm going to look at changing the numerator. 1 marathon is 42.195 kilometers. So I know kilometers is going to be one of my units somewhere. Okay? But first, I want to cancel out the centimeters. I want to get that out of here. So what if I do 1 kilometer over some amount of centimeters? Well, why would I do that? Because I want to cancel out this kilometer, right? Then I could possibly do a marathon over a kilometer, and then I could get these canceled out. That's why I would do 1 kilometer over something. Now, we want to cancel out centimeters. So how many centimeters is in a kilometer? Well, 1 kilometer is 1,000 meters. And 1 meter is 100 centimeters. So 1,000 times 100, or 100 100,000 centimeters. Don't forget your units, guys. So 100,000 centimeters, what we have here. And then what do I multiply by? Now I have the kilometer on the denominator, right? Kilometer, whatever, right? So centimeters can cancel out, but now I need kilometer to cancel out. How do I do that? I need to put kilometer on the denominator. So 42.195 kilometer. And then what's going to be in the numerator? 1 marathon, or 1 MA. Now, I can successfully get 1 marathon on the numerator, right? But the fortnight on the denominator is still not sorted out. So let's sort that out then. Now, we know that marathon is going to be in the numerator. But then how do I change the second to make it into a fortnight? Well, you see over here, 1 fortnight is 14 days, right? So I can write it down like this. I know fortnight is going to be in the denominator. So I can write down 1 FN and then 14 days. But how do I change days to make it into seconds? Or how do I get rid of these days and get rid of seconds as well at the same time? I can represent it in seconds per day, because then I can cancel out this seconds and this seconds, the S over here and the S over here, and the D over here and the D over here. Well, how many seconds are in a day? 24 hours, right? And then each of those has 60 minutes. Each of those has 60 seconds. So if I was to pull out my calculator right now, 24 times 60 times 60. So 86,400 seconds per 1 day. Now, I'm good. That's it. Because the days cancel out, the seconds cancel out, and then I'm left with Fn on the denominator and marathon on the numerator. I just need to multiply out all the units on the numerator and divide it by the denominator. So 1.3 times 1 over here times 1 times 14 and then times 86,400. Okay? All of that over 100,000 times 42.195. So now that would end up being it would be 1,572,480 on the numerator, but then we divide that by 100,000 times 42.195, which gives us 0.37 marathons per fortnight. That's your answer. Okay? So, same method. You try to see what you can do to get the numerator and the denominator to become the units that you want. And then you keep on canceling and going along, right? It gets very easy as you do. Once you do the first one, you kind of understand what you need for the second one. So you unwrap it and you keep going like that. So you can see here, right? These are your answers. Thank you for listening, and then next video we'll be going over trend lines and slope, as well as graphing using Sultan, okay? So if you like my video, give me a like and a follow so you can watch more content like this. And also be sure to check out my website, OTS, which has multiple practice problems as well as videos similar to this and can help you on your educational journey. Thank you for listening.